Recording in progress.
Hey everyone, it's March 21st, 2022. We are in Computer Science 1, Introduction to Programming. We're using C++. Today we're looking at structures and methods. On Wednesday, the syllabus says that there's going to be a workshop. Instead, I'm going to do a project. I won't be able to be here until about 4:30, maybe 4:40. And we'll do a project in class, just like how do we start using this information to start from scratch on stuff. And so I'll send an announcement with it, but I thought I'd let you guys know. Let's just start with something simple. We all know about our integer x. This is x is a variable, but x is also an object. So we are starting our object-oriented programming, or OOP. So x is an object, effectively, of the integer data type. We can create our own data types, though, and that's what we're going to look at today. Let's look at creating our own data types. And these are called structures. And later on, we'll do classes as well, but today, structures. And the command we use is struct. Not structure, but just struct. And then we give it a name. Unlike variables we tend to use lowercase to start with. Structures and classes, we start with a capital letter. So let's just make one that's about a person. And these go above the main. Structures or structs go above the main. We might have some implementation down below with methods, as we'll see later on today. But I can just define what makes a person. We have names, right? Let's go with string last name, string first name. We all have an age. And so I'm just creating variables that apply to people. We all have weights. We all have heights. That might be a little more complicated than we need to do right now to illustrate the idea, though. We can have multiple different types of data types within these structures to help describe what's going on. And when we declare them down in here, you call, once you have it, I've got the structure person. I'm going to say person like I'm introducing int. Person, we'll just call it dude. Dude is going to be my name. The name of my object. So dude is an object of the structure person. And to populate it, well, I can't just say dude equals Jones. Like, that's my last name, but it doesn't work. Notice that it doesn't work. It doesn't like it. So when we're doing stuff like that, you can type dude and then hit dot. If I hit dude and then dot, it gives me a list of all the variables I've created inside the structure. So I can just choose. I can start typing one. It narrows down the list. I can hit tab. This is a nice convenient function of our IDE, Visual Studios 2022. Yeah, sure, I'm 21. Yes, I'm 21. And so I can populate or instantiate my person, my dude, by entering these in. And we use that dot operator to go access the different variables. Okay. And maybe we should create a function that prints a person. So let's do void print person. We got to pass in person as an argument. And I'll come down here and make the function. So we can create functions that use these as input variables. And so let's see, person, we got first name, arg dot first name. So we got to use our dot operator thing in here as well. And maybe we'll put a space between the first and last. And so I've created something that should print out their first name and their last name and give their age. We need to use it though in the main. To use it though, we got to call it print person. I'm going to pass it dude. And let's just give it a run. Let's see how it works. David Jones is age 21. Bam. Not bad. It's pretty easy. So let's say this is for my boss. And my boss says, dude, what the fuck? Everybody's got a middle name too, which we know isn't true. But we're like, okay. All right, boss. Let's add in a middle name. And conveniently, when we have these structures are very extensible. Just because I add a new variable, I'm going to run it without adjusting that middle, without putting in a middle name, and my code still works. So by adding in that middle, I've kind of effectively made the old code legacy code, but it still works. So adding in new stuff, in new variables into our structure doesn't break any legacy code, which is nice. So maybe that we go ahead and enter it. Dude, middle name. My middle name is Awesome Sauce. And I guess if I'm going to do my print person, I should edit that now to include that. Dude, or arg middle. You don't like me? Why are you? Oh, I don't have an equal sign. That's why it's calling bullshit on my Awesome Sauce. I'm like, it shouldn't care what I got for my string. That's some bullshit. David Awesome Sauce Jones is age 21. So we can do stuff like that. Notice I've got different types of variables in there. I've got an integer. I've got strings. For the sake of doing strings, I'm going to condense this down to just name now. Let's just get this down to name. Undo. And I'll comment that out. How about we do that? And we will add in name. That'll break the legacy code. We're coming out that one. We'll make a new one. So I just got rid of the old one. Now we're just using a regular just name. No need to make it long. It's about to do end line. And that'll still work just fine. So adding stuff in is fine. If we change stuff, then you got to change code. Like I got rid of the variables I had before, so then I need to change it. But all that works just fine. So here we had a function that took in a person, function that took in a string, or not a string, took in our structure. And now let's look at one that returns a structure. Let's see. Oh, let's just make one that creates a person. Like let's say we enter in string arg name, and we'll enter in an integer arg age. And I'll copy this and put it down below. So functions that return a structure. Oh, I already wrote it. So I'll make a temporary person here. Temp dot name. Since it's a person, I can use that dot thing. Equals arg name. Temp dot age equals arg age. And we'll return temp. And so all of this code, let me move this up above. All that could be replaced with just one simple thing. We want dude to equal my person, David Richard Jones, 21. And that should replace it. I'm passing in David Richard Jones as arg name, and arg name is being assigned to the temporary person's name. I'm passing 21 in as arg age, and that's assigning it there as well. And let's just see if that works. And voila. So functions can take in these objects, they can print out or return these objects. This is another way to instantiate an object. I can also make another person. Let's call it you. Oh, there we go. Person you. I can also do this all at once let me be specific. Making it with braces, making an object with braces requires using the variables in the same order as in the structure. So my structure has named an age. So David's here. We're going to use David Ferris. David Ferris he's 21 like me. He's pretty awesome. And I can print person on David Ferris. Or I print person on you. So that's another way of populating these objects, these structures. So it's almost like string is that way. String is an object. String is one of these things that was like it used to be a structure for, well, it was a C string array for C, and they said, you know what, let's make this an embedded object, embedded structure for C++. We're just gonna put it in there. It's all behind the scenes. String is like this. In fact, you'll notice person, when I use it here, has the same color as string. The IDE is identifying this as a object or a class structure. What else did we do with these variables like integers and characters and strings? We did arrays. So we can do an array. Let's constant size, let's say 3. And I think a good name for a person array was maybe people. And let's see, we'll populate people 0. We can do just treating it like a regular array. Is my person David Jones. People 1 is David Ferris. And who else do we have in here? Where's my participant list? Lise. People 2. Let's just copy this whole thing. Rubio. Oh, yeah, let's use a 0 rather than an O. And these people 2. And so I've made this array. There's a couple ways to print it out. I could do a good old for loop for int I equals 0, I less than size, I plus plus. We want to do print person on people bracket I. And that should work. Let's comment those out up there. So I've made an array of size 3. It's called people. I've populated it with the 3 of us that are in the presentation right now, our Zoom thing, and then we're going to print it out. There are build errors. What did I do wrong?
You have print person up top, only 1/ for your comment.
You're right. Try that again. There we go. Printed all of us out. We could make alternatively, more along the lines of our arrays, we can pass in an array, void print person array, and we'll take in an array, and we have to take in that size as well. Come down here and we'll make it. And effectively, we are doing exactly this. Except it's not called people, it's called arg. There we go. Use parentheses rather than braces. It just messes everything up. So we'll comment that out. And try using our print array person. We pass in people and we pass in size. Whoa.
Zoom back.
Same stuff. There's a lot of stuff we can do with this. This is pretty cool though, because like when we did integers, we were just assigning a block that, this is the block we call 3. It's got an address. I make this structure called person. Originally, I had last name, first name, middle name. So we needed bigger blocks for that. And it had info for an age. First, middle, last. But it's still pointing to this object right here. This thing has a starting address. It's got to have an address just like X does. So what's the address look like? Let's just take a look at the address. It's going to change each time, so maybe let's put dude back in. Dude's coming back in. Dude's already in there, so I can just do it. Let's just see out the address of dude. What's the address of dude give us? The address of dude, well, that's in hexadecimal, of course. It's telling me where the person in memory, where it starts in memory, where it's starting up. But we could take advantage of that. Let's see, what do I want to do with this? Let's make a pointer. We did pointers, right? Let's talk about pointers. How does pointers work here? So we know dude has an address. So I can make a person pointer. Let's call it purse pointer. And we'll just set that equal to the address of dude. And so if I want to access it, we've got to, we got to do the whole dereference. And then I can do last name or name. And if I do that, I can access this stuff through a pointer. So we've used pointers. We can use the pointers. Let's turn off that. There's another way to do this, though. Watch what happens if I forget that person pointer is a pointer. And I try to do the dot. It gives me accesses to it. Now, this is specific to the IDE that I'm using, Visual Studio 2022. But if I do the dot, I shouldn't be able to, because person pointer is an address. But it goes, well, I think I know what you're doing. You want access to this stuff. I'm going to say I'll do age here. And I hit space, and look what happens. I typed pers pointer.age, and it shifted to pers pointer arrow operator age. That's another way of getting stuff that's through a pointer using this arrow operator. You're going to do this a lot in CSCI too. When you're doing linked lists and good stuff like that. You're channeling, going from vector point to vector point. Along the way, you're going to use this pointer thing to jump to the next thing in the chain. So these these arrows work really well, but this is a shortcut to doing it. I need to end that thing. And if I do that, there's my 21 right there from the arrow operator. So the arrow operator, let me put it over here, continue. We could either dereference a pointer and then do dot with whatever, or if you want to skip the dereferencing and go directly to it, you can use the arrow operator, which is the minus sign and then the greater than symbol. That is definitely something you can type. And then you put the same thing. So I'll do that here. It cheated. It was a cheater program. It did the jump for me. But to illustrate that I can do it, I'm going to do the minus sign and then the greater than sign. And now it gives me that list of options.
You remind me what the value of pointers is as opposed to just referencing the original article.
Pointers, well, referencing with the address is just fine for a lot of stuff. Referencing the address and pointers for a lot of things does very similar stuff. It allows you to access the information without transferring or copying it over to a function. As we go further down the rabbit hole, there is stuff you can do with pointers that you can't do with referencing, like jumping along a chain in a linked list and stuff like that. For now, it's more of a, here, let's introduce you to it so it doesn't look absolutely foreign when you get to CSCI 2.
Okay.
When you do it in CSCI 2, it's going to pop up a lot. Excellent question, though. So maybe let's make let's comment these out. Let's try another structure. Let's create one called dog. Let's make a dog. I got a dog. I love my dog. So I'm gonna make a dog operator, or not operator, a structure. And let's see, dogs, they have a breed. They got a name. I'm gonna go with name first. They got a breed. What else could we put for a dog? Maybe their age and their weight. Gender, I could use male or female. And I could use a char for it. If I use size, I did like small, medium, large. I could do SML. I could use a char for that. And so we got a bunch of stuff going on here, right? And if I know the right order, well, I can do them one at a time. Let's do this up here where I can still see it. I'm going to make a dog, and he'll be my pet. And we'll just populate it one at a time. My pet.name. My dog's name is Astro. And breed is another one that I wanted. He is a teacup Maltese. Age, oh shit, how old is he? I want to say he's 8, maybe, I don't know, 7.9. It's a minus sign. I think we got it. I think he was born in May, so he's not quite 8. I did minus sign again. What a lop. Hit the right key, Jones. My pet, his weight. He's a whopping 5.2 pounds. He's small. which brings up his size. He is extra small. I guess that's not a char though, so we'll just go with small. You know what? T for tiny. Chars though are single quotes. There we go. And he's a boy. And we could make a, and I'm not going to do it, but we could do a void print dog as well. Same idea. The point is to show that the structures can include a lot, which makes them awesome. The structure, this is really, structures are like a template or a design. And when we create the dog, right down here, I created or instantiate, or I created an instance. 1 second. I'm in class. Can I call you in like an hour? Yeah. Okay. Bye. So I've created an instance of the template above, structure, dog, and below I populate it. Just to go over some terminology. You know what? I am going to do a print dog. Dog is pretty big. I don't want to print, I don't want to make a copy of the whole damn dog. So I'm going to pass the dog by reference. That was lame. Do it right there. And maybe I don't want to print out everything. The dog's name is arg.name. Breed. Arg.breed. And if we wanted to put more in it, we could. I'll just come up here and point out passing by reference is often a good thing to do. Where's my dog? My dog's right here. So we'll do print dog. And we're passing the address of my pet. Why is that saying no?
So why is the ampersand and behind dog in your function and in front of?
That should have been fine.
I'm asking. I'm not saying that was the problem.
That should have worked. Should have worked either way. Oh! No, that's not it. There was it. Something was off. It wants the address or the ampersand in front of the... Okay. So, yeah. I get pointers, it'll take it in either spot generally. I guess it specifically wants it over here. I wonder if that's IDE specific or not. I'll have to look into that. Let's grab something from the lecture notes. And I'll embed them over here real quick. Copy, paste. And I need to go over and make sure I grab the code. So I've got this rectangle. Let's see, the rectangle has width, length, and units. And we've got two things to calculate the area. One set up with it, one set up without it. Notice theirs has got it after rectangle, not before arg. So I'm wondering if I just had something off key or something. Let's comment all this out while we're looking at it. Let's comment out the dog. Let's have our stuff at the top. Hell, let's even speed it up and let's grab what they put there. In their main, they have this. So they've declared they're going to make an array, it looks like. They've done rectangle, my rectangle. They've populated, this is from Eddie, former teacher here. He made this code. Length is 3.4, width is 2.5. Units are in centimeters. He's got them set up as doubles, that's good. He's got a perimeter thing. And maybe we could make a function for it. Where he accesses all the stuff. And he's also set up an array where he populates the array when he makes it. So adding a little bit of spacing might make it a little bit easier to read. He's got it printing out the unit, printing out units. Interesting to see out. And then he's doing the area, passing it by. Ow! That's what I had different. I didn't need to tell it. I was typing address, my pet. I didn't need to type address. That's what's different. I was typing address here and I didn't need to. When I got rid of address, it worked just fine. What's going on? Stop that. We click run. And it's telling the units of the individual things. Let's make a function for that perimeter, but we're going to do something better. We've already seen these functions. This is boring shit, right? Let's put the function inside the structure. A function inside a structure is called a method. It automatically has access to any variables in the structure. So we don't need to pass it to it. If I were to make a function for area, I would need to either pass it a rectangle or pass it the length and the width. I can just make a function. Let's say I want it to do a perimeter. I want it to be a double. We'll call it perimeter. And I don't need to pass in the length and the width because I already have it. But what changes when I make a method rather than a function? So we'll call this method implementations. If I do this, if I say return 2 times the length plus 2 times the width, I have a problem. It doesn't recognize length or width because it's thinking perimeter is a function. So right now, it thinks it's a function. The way we get around it is we use the scope resolution operator. I tell it it's a rectangle, and then I do double colon. The double colon is the scope resolution operator. It tells the program what stuff it should have access to automatically. What is its domain? What is its scope? And if I do that, notice it goes away. The errors that I had in there go away. And now if I want to reference it, let's comment out. We did the perimeter thing. Let's just change this. See out my rectangle. And now notice, look at that. My variables, length, units, width, all show up with this blue box. This is, of course, Visual Studio's. Methods show up, well, they were rectangles, funnily enough. The method shows up as a cube in the picture. It's a purple cube, but it shows up on the list. Since it is a function that was like a void, I do need to give it the parentheses thing now. And I can comment out that one. Actually, let's just take this and put it right where this was right here. Let's replace that. So I don't want that one. So that's pretty cool. So we can make functions inside of method or inside of structures that automatically have access to everything that's inside of it. And so we could kick up his rectangle thing a notch. Like, let's say we're doing stuff in Unity. I know Unity or, Roblox uses different code. But let's say we're making bricks for Fortnite or something like that, and it uses C++. No, Fortnite is 3D. We're not doing 3D. Let's say two-dimensional, like those old Arkanoid where you hit the ball and it keeps going up, breaking the bricks. We're doing something like that. Let's add some stuff to the rectangle. Maybe it's got a fill color and a stroke color. And maybe it's got a stroke width. Like the width, the stroke is the shape of the box. How thick the line is the width. And let's comment those out. And we can go in and add more stuff to it. So fill color is, I don't know, red. And we'll make a stroke color. I don't know, magenta. And this is obviously not a graphics setup, so you're not going to see the box. But if we had a graphics thing set up with it, this is one way that you would make those adjustments. Stroke width, we want a good size line. I don't know, it'll be 5 wide. So that's one way of going through it and editing stuff like that and adding to it. Does that make sense? I think I went through all that kind of quick. If I make a pointer for this, something else we can do with pointers. Well, you've already seen we can, once we've already got a value, we can reassign the value. It's just like a variable, so I can change the value. If I have a pointer, the address of my rectangle, I can use pointers to change stuff. Do the arrow operator, we can change the width. Why does that have a star next to it? Maybe that's the last one you, that's got to be IDE. Telling me the last thing I used, maybe. Let's do something else. Let's change the length. So we can edit stuff like that. That's kind of boring though. Let's make it a random length from 0 to 10, which means I want to include C time. You know what? I did strings and I didn't include string. Fail. That was me failing as an instructor. I was relying on the IDE to do stuff that I was supposed to add. What the hell just happened there? Undo? There we go. Students do it too, and it sucks because Visual Studios doesn't tell you that you've made some assumptions. But if I tried to run this in another IDE that doesn't fill that stuff in for you, it doesn't work. So you really need to add that shit in. Back here to making my rectangle fun. Where was my rectangle? I'm going to make the width. I want to make my width random. I'm going to do rand mod 10. Oh, I need to seed it. I'll do seeding in a second. And then I'm going to add to it. I need to convert it to a double because rand spits back integers. But if I do rand divided by rand max, I get a number between 0 and 1. And then converting it to a double makes it stay as a decimal. So this is 0 to 9 plus 0 to 0.99999999999, which effectively makes this 0 to 10, or 0 to 9.9999999. We do that. We can have some fun that way. We seed it. srand, seed random. Time equals 0. I'm totally blanking.
Time parentheses 0.
Thank you. Totally brain farting. Or you can use null instead of there, in 0 instead of 0. Let's turn that perimeter back on. Let's turn this back on. See what the perimeter is now. I know the length is going to give me 15.1 times 2 is 30.2. Let's make that 15.0. Let's see how much the random width adds to it. Whatever 4.175 is divided by 2. So, that's a lot of fun stuff we can do with structures. I'll give you guys, I think that's all I really have for today. I'm going to do a project. We'll do another project on Wednesday, starting at like 4:30. I'm going to try to be here by 4:30. It might be 4:40. I think Andre's still out this week. He's still taking his tests, his placement tests, or I think they were his placement tests.
So what are you defining as a project?
we are going to make, we'll go over it. We'll talk about it then. It's just going to be like, how could we start from scratch and figure out what to do?
Okay.
We're to give you a little prompter for it though. We're going to look at making a structure for a triangle. So we might want to look at what should we use for variables for a triangle. What kind of things can we do methods for a triangle? And then we'll go from there and see what we can come up with. So that'll be
Okay.
next week's project. And we'll do it in class. It's not part of the assignment, but it's like a way to start from scratch and go, okay, what could I possibly use? We'll explore different options. Like if we think about it, we got a triangle. There's several things that we could use for variables. We could use the lengths of the sides. Like if we have 3 side lengths, that should give us the shape of a triangle. We could look at the 3 angles that make a triangle. We could look at the 3 points that make a triangle, and we'll explore like what makes for better ideas than others. And then we'll go along the lines of how do we go about like generating all that stuff, using methods and stuff like that. It'll be good times. Any questions? I got that done way faster than I thought, and I think it's because I actually organized my thoughts. This took Redden 3 hours to present on because he just wanders all over the place. And I collected my thoughts, put them in order like what we've done in class. We use them as variables. We treated them as functions, use them as inputs and outputs for a function. We looked at trading arrays and pointers with them. And then we looked at switching functions to methods inside of them. And we'll explore these methods more. Just like we had right here, dude, doing something like that where it auto fills in information. We'll make something called a constructor method. Not with the triangle, but when we start doing classes in chapter 10, where it has a default setting, but it's set up very similar. And I think that's a wrap. If we don't have any other questions. Lise, any questions from you? David asked along the way.
I don't have any questions.
All good?
Yeah, all good.
All right. Well, we'll call that a wrap.
Bye.
If you've got to go to class, you can go now, or we can. I think you have class.